Heyo, welcome back once again to another one of my Mr. Marcus math tutorials. All right. Okay, so yesterday we did volume of rectangular prisms. Today we're going to move on with volume, and we're going to do volume of cylinders. You may be familiar with this shape called a cylinder. We're going to talk about this shape. We're going to talk about how to find its volume, and we're going to talk about the special mathematical character that has to go along with shapes that have rounded edges, rounded surfaces, because they don't have necessarily a length, width, and a height. So let's get started by just reviewing what we looked at yesterday, and that would be what is volume. So volume is pretty much summarized as the amount of space something takes up. You could also look at volume as being how much it can contain. That's really more of a measure of capacity, but usually capacity and volume have the same measure. They're just measured using different units. So we only use it on three-dimensional figures, like the one that we're talking about today. The specific three-dimensional figure is going to be a cylinder. So let's see some examples of what cylinders might be so that we can make sure that we're all on the same page as far as what is a cylinder. So a cylinder has two round sides and one lateral surface. It looks sort of like a can, is usually a pretty good example of a cylinder. Obviously, this battery right over here is another example of a cylinder. This soda right here, another example of a cylinder. And finally, we have a scented candle to set the mood for what is a cylinder and how do you find its volume. So, in the last lesson, we spoke about length, width, and height, but obviously looking at an object like a cylinder with rounded surfaces, it's not necessarily going to have those kind of dimensions. So what dimensions does a cylinder have? Well, because a cylinder involves a circle, it has a radius. If you remember from earlier years, a radius is half of a diameter. What I'm highlighting in purple right there. The radius is half the distance across the circle. The blue highlight shows the height or the length of the lateral surface. These are the only two dimensions that need to be used when finding the volume of a cylinder. So let's go. Here's our first page, cylinder in red, right here, generic cylinder. Because this shape does have circular sides, we're going to have to use our old friend pi, which you might remember from earlier lessons that you've done with area of a circle. So in this case, pi is what it always is, the relationship between a circle and its diameter. We're not going to use the diameter, we're going to use half of that, so that's the radius. So pi times radius squared times h. We substitute the 5 where the radius was and the 10 where the h was. 5 squared is 25, and then times 10. That's pi 250. Notice at this point I pull out the calculator, because pi times 250 is 785.398. I'm highlighting the 3 and the 9 because I'm using the 9 to tell me how to round the 3, and it rounds up to 4. We're going to do a couple more like that, so don't worry if you didn't get it on the first try. And remember, you can always re-watch all of these slides on the video as many times as you want. I would like to recommend that you watch the videos, but obviously those of you that are watching this are the only ones hearing that I'm recommend watching it. So once again, now we're on to blue cylinder. In blue cylinder right here, we have it seem to be turned on its side. This is irrelevant. It's still a matter of looking at the radius and the height, and they only go in those spots in the formula. Same formula, pi radius squared h, where the radius is 3 and the height is 8. I've substituted those in. 3 squared is 9, and I put the 8 in parentheses because I need to know that I'm multiplying. 9 times 8 is 72. Pull out the calculator. 226.194 and a bunch of other numbers, but I want to round this. So I'm going to look at the 9 to tell the 1 what to do. The 9 tells the 1 to round up. So I rounded to the nearest tenth at 226.2, and remember, volume is always cubed. Many of you on the last quiz chose answers where the answers were squared. Squared is for surface area, not for volume. You can't fill anything with squares, but you could fill something with cubes. Cubes take up space. Squares are imaginary two-dimensional figures that describe the shape of something, but don't take up any space on their own. Okay, cylinder 3. Still a cylinder, but looks a little different than the other ones. In this case, it seems the height is shorter than the radius. That doesn't matter. You put the radius number where the R is and the height number where the H is. So here I'll substitute the 7 where the R is and the 3 where the H is. I will then go and square 7 to get 49, put the 3 in the parentheses to show multiplication. 49 times 3 is 147. Pull out the calculator and then get 461.814. I then look at the 8, because that's the one I want to round to, and I'll use the 1 to tell me what to do. The 1 says to the 8, stay right where you are. So 461.8 inches cubed is going to be my final answer there. Okay. It's very important that we completely keep in mind that all volume measures are cubed, or as it said on the last quiz, with a little 3 as the exponent. Squared is used for surface area, which is not something we work on this grade, but it's something you've worked on in the past. Squares tells you things like the floor, or how much carpet, or how much wrapping paper or paint, but volume is used to measure how much space it takes up. So how should we display our answers? Do we use the answer that was in terms of pi? Do we use the answer that the calculator gave us? Or do we round the answer to the nearest whatever it asks for? Well, this really is an issue of how the question is asked. If you're asked to leave your answer in terms of pi, you leave your answer in terms of pi. If you're asked to round your answer to a certain place value, tenths, hundredths, thousandths, wholes, then that's what you do. Okay? The calculator can only give you an estimate of an answer because the answer is using pi. And pi is an irrational number with a never-ending chain of decimals, so it never is going to give you an exact answer. So it's going to be up to you, especially on the quiz today, to answer the questions the way they are asked. And make sure that you're being extra careful to look at all the choices first, because in the last one, some of you said that the choices were tricky, or that it was like somebody was trying to trick you. That's not the case. You just need to be more careful, examine the answers, and choose the best answer to the question. I heard from some of you that sometimes the portions of the video go a little quick, and as promised, I'm going to break down at least one of the slides so we can see exactly what went on. So here we're starting with the formula. You literally just write this down on a piece of paper, pi r squared h. From there, I'm going to replace the r with the 3 because that's the number that represents the radius in this question, and the h is going to get replaced with the 8. Then I'm going to do 3 squared. You might have this on your squares list. You may know what 3 times 3 is, or you may feel like picking up a calculator. In any case, 3 squared is 9. I put the 8 in parentheses. Then I go like this. 9 times 8 is 72. Then, when I have to use the calculator, I say, hey Google, how much is 72 pi?
The answer is approximately 226.194671.
So obviously you can use that. I wouldn't recommend using Siri because she'll probably give you a recipe for some kind of pie, but that can be the way that you find the answer. You can also have a calculator. That calculator must have a pi button on it. If you don't have a physical calculator, there are limitless calculators on the internet, including the Google calculators, that can give you a pi button so that you can use it. And when you're entering it, you can use a multiplication symbol, or you could literally press pi button 72 equals, and it will give you the same answer that Google gave me. Good luck.